So imagine this is you, the Japanese bush warbler, your full legal name being Satia Dephone. Your native hometown is Japan, but in 1929 you were taken to a new home, the island of Oahu. After a couple decades, some individuals migrate to the nearing islands of Kauai, Molokai, Maui, and Hawaii. Then you were attracted to a song or alarm call and were captured by some researchers. 143 birds were all taken from the other islands, including you. Then some pectoral tissue were taken from you and the others for genetic testing. The samples were extracted for DNA, which was amplified in a polymerase chain reaction, making multiple copies. These were then categorized into 12 microsatellites. Microsatellites are repetitive DNA sequences that are often used as markers. The study showed that your move had actually modeled genetic drift, specifically the founder effect. Genetic drift is a change in allele frequencies within a population. There are two main ways, the founder effect or the bottleneck effect. In the founder effect, which we'll be focusing on as it relates to the study, some individuals from the original diverse population migrate to a new area where, after generations of repopulation, the diversity is decreased, as a small population of individuals do not represent all the diversity from the original population. The researchers used genetic diversity as a measure, which was assessed by observed and expected heterozygosity and the average number of alleles per locus. Heterozygosity is having two different types of alleles. Alleles are variants of a gene, and a locus is a specific location. The study found that the Oahu birds were the most diverse, and this had reduced in succession to the furthest islands. This was expected due to genetic drift. Essentially, the distance of each island from Oahu, the original home of the birds, had a marked reduction of diversity. That being, the greater the distance it was, the greater the loss. For example, the island of Maui had more diversity than Hawaii, which is further away. In conclusion, the study had modeled a population that underwent microevolution where genetic drift had occurred. Limitations of the study are that genetic markers rather than selection was measured, and the study only captured early stages of evolution rather than the long-term effect. Strengths of the study include multiple samples, the history of the migration was well documented, allowing for a rare natural experiment. The use of microsatellites was also a strength, as they are polymorphic, easy to detect, and small genetic variations can be found and be used to determine population structure. I found that the study had fascinated me as it brought many information and skills I had learned in Gen 2052 together, specifically elements of genetic drift in population genetics, as well as a focus on genetic diversity and how it alters allele frequencies. Migrations of these birds represented the real world applications of genetic drift. I also learned the intricate tests and databases that was necessary to determine genetic diversity. I'm interested in exploring how these concepts can be applied to endangered species in an attempt to preserve them. Additionally, to find out the reason why it took the birds more than 50 years to start migrating and colonizing away from Oahu, which is still unknown at the moment.